Done. Okay, that looks good. Let me go ahead and hit save. Let me share my screen. All right. Start here now. Okay. Uh-oh. Hit paste. That's interesting. Okay. Let's see. One more thing. I'm gonna hit save over here, and I'll just check attendance again at 10:15. So I'm not doing so much back and forth. Let me think about it. So this brings us to the end of week 5, right? So we had exam 1 that was due at the start, like on Wednesday at the start of class. And again, with all of our assignments, we get unlimited attempts, and you can work on all assignments past the due date with only a 10% late penalty. Also, just to remind you, there's a hard deadline for all assignments, which is going to be, I think it's like May 1st, which is that Sunday night going into Monday at midnight, at the top of the week of finals. So once we start to move into the week of finals, everything's going to lock out. Once we get into the week of finals, the only thing you're going to have access to is our final exam on Pearson, right? So you want to just do the best you can to get everything in order as soon as you can. And you can honestly get ahead on all of our assignments. If you finish all your homework and quizzes early, then the only thing you're going to be responsible for is just getting your daily attendance credit and just get your exams in order, right? And as always, if you have questions or concerns about things, feel free to unmute yourself and just get my attention. Let me check this one more time. I got 4. Okay. Edit. That's one. There's 1. 2. 3. Okay. All right. So we're just going to kind of continue last time. We're working on section 3.2. I think we got about halfway through all of the assignments. So we'll just pick up where we left off. Just resetting my attendance. And also, it is a good idea to be subscribed to my YouTube channel with all of your notifications turned on. So that way, like sometimes I just go live at random times. Like usually I'm like doing a lecture or whatever, but if you see that I'm live, you're welcome to like join in. You can hop into the Zoom, ask me questions. It's just be like impromptu, like office hours, right? Like I'm totally okay with that. But that's, you know, and also it's a good idea just to have your notifications turned on, all of them, because you know, sometimes students ask questions like they do like here in the lower left-hand corner, the ask my instructor. When students use that, it'll send me an email with your very question. I'll be honest right now, I do not check my emails because I just be busy when I'm not with you guys, but it is on file. And so like once you get it to my attention, then, you know, I'll load the question to my tablet and, you know, I'll do a dedicated YouTube video walking you through whatever questions you guys send me as best I can. Let me think. Okay, so with that, let's kind of keep going with this. So it says find the domain, right? So I think last time we mentioned something about logs. You can't take the log of 0 or negative numbers, right? So that square root of x plus 5 has to be greater than, let me think about it. Yeah, it has to be strictly greater than 0, right? Because we can't take the log of negatives. So we need to set that square root of x plus 5, that needs to be strictly greater than 0. We just here, let me just, instead of trying to explain it, let me just write it out. Let me get a copy like this. That's fine. I'm not gonna use that. This is good. All right, we're gonna take this. All right. Well, I did not check that pen. Hopefully my pen has some juice. It's not giving me trouble. Everything to do is give me trouble. Let me at least on my charger, so when I'm not using it, it can be charging. Okay. So we're asked to find the domain, right? So again, in general, we can't take the log of 0 or negative numbers. So this square root of x plus 5, this has to be strictly greater than 0, right? I want to say we can square both sides and we'll still have this. X plus 5 is strictly greater than 0. Subtract 5 on both sides. And so x is strictly greater than negative 5, right? So then if x is strictly greater than negative 5, are we talking about all the numbers to the left of negative 5 or all the numbers to the right of negative 5 on a number line, right? we're talking about all the numbers to the, hopefully you're thinking right? So all the numbers to the right are going to go from -5 to infinity. In this context, infinity always gets parentheses. And because there is no bar here, that means we use a parentheses. If there were a bar here like that, we would use a square bracket, but no bar means parentheses, right? And what parentheses means is that we get really, I mean, infinitesimally close to that number, but we don't actually include that number, right? So this will be the interval notation. Okay. Let's see, style, come on. Like this. It's copy. Let me hit save. I think we are good there. Okay. Copy. Okay. What did it say? Negative. Let's see. So I gotta hit this X. Okay, so we're gonna do parentheses. It says type your answer in the interval notation -5 to infinity. Okay, let's see, how do we do? All right. What time is it? I'll check Zoom in like about 6 minutes. I wanna let the 10:15 mark hit. So it says the figure on the right shows the graph of f of x equals log base 4 of x. Use transformation of this graph to graph the given function. Find the graph's vertical asymptote, domain, and range. Okay. So it says, which of the graph, right? Let's see. Okay. So we have this log base 4 of x plus 6, right? Notice that +6 is inside our basic function, right? So we manipulated the inside of the function. So inside manipulations typically cause a horizontal change. It's going to change it side to side in some way, right? And another thing about inside manipulations is that it's typically the reverse of our intuition. So if we add 6 on the inside, your intuition might say, oh, well, positive goes to the right by 6, but actually this is the reverse, it's going to go to the left, right? Another way you can kind of visualize it is like, well, -6 makes that 0, so that means we go to the left by 6, right? So we take the original graph, which you see kind of to the right there. Here, let me zoom out so I'm getting better view a little more. So we take that original graph and we just move it to the left by 6. Okay. So the only one that moved left by 6 is D. And we're just going to go with that. The vertical asymptote. So normally the vertical asymptote is going to be the y-axis, but if we go left by 6, now it's going to be x equals -6. Okay. All right. The domain, right? So normally the domain of a log function is 0 to infinity, but because we moved it left by 6, now it's going to be -6 to infinity. Negative, no, let's do it like this. It's going to be -6 to infinity, right? Infinity always gets parentheses. And again, normally the domain is the open interval from 0 to infinity. So that means we need to keep it as an open interval. In other words, it cannot be equal to -6 because that's going to try to take the log of 0 and we can't take the log of 0. So that means the -6 gets a parentheses. Okay. The range in a graphical sense is going to be the very bottom to the very top, right? So I think we have the graph here. You see it in D. So the very bottom to the very top, the range of, one way to remember the range of the log is the same as the domain of the exponential function. In either case, oh, come on, you are like bugging today. Let's go like this. In either case, they are both negative infinity to positive infinity. Let's do one more question, then I'll check Zoom one more time. For the following function, briefly describe how the graph, let me see. So basically transformations again. So base function is just a generic log function. And then we did a +1 on the inside. So that's an inside manipulation, which is going to cause a horizontal change. This is going to move it to the left by 1 unit. So the graph of this can be obtained by translating the graph of log of x base 2 1 unit to the left. 1 unit to the left. Okay, let's go with that. Okay, it says, oh, and then use the graphing tool. So if we click, so the log function with the options, it's going to be on upper right. That's the graph of the log. It says click to plot. So I'm just clicking anywhere on the graph. And the only manipulation, we have our base 2 already. We said a horizontal shift left by 1. So I'm just going to slide this to -1 to make it go left by 1. And the graph looks good. That's not right. Let's see. I'm clicking on the graph again. Horizontal shift, reflect. Why did it reflect? We're not reflecting. Yeah. And I think it still didn't come out right. That looks good. And that needs to be a 1. There it is. Right there. Okay. That looks better. Okay. Yeah, we just moved. All it is, we just the base 2 and we moved it left by 1. Right. Let's hit save. Oh, let's check. I don't know how and why it was automatically like inverted. Let me do one more. Oh, what's the domain, right? So looking at this graph, again, the domain is the very left to the very right. So again, normally the domain of log is 0 to infinity, the open interval 0 to infinity. But because we shifted the entire graph left by 1, now it's going to be the open interval from -1 to infinity. So double parentheses, -1 to infinity. Okay. All right, let me, the vertical asymptote. Normally the y-axis serves as the vertical asymptote. Because we went to the left by 1, now it's going to be x equals -1. Okay. All right, let me check Zoom one more time. Okay. Let me get the student. Edit. Let's see. Section 3 today. Next. Okay. Yeah, let's let him in. Let's get back to it. Let's see. So this one asks us to let's go like this. Graph the function by using transformations. Okay. So normally when that base is strictly larger than 1, I want to say you have it where it's steadily increasing. But with that base being between 0 and 1, I want to say it's going to cause, like, it's going to be decreasing, steadily decreasing. Okay, here, let's click the graph, right? The log tool, okay, the upper right is the linear tool. The second row on the left is absolute value. Second row on the right is a quadratic or parabola. Third row on the left, what is that? That's like x equals y squared. And then the log function is the third row on the right? That's the log function. So click to plot your curve. So I'm just clicking on the graph. Now our base is, we're going to say base 1 over 7. So it's not base 10, it's base 1 by 7. Okay. And then we also have, we multiplied the inside by a negative, right? So inside manipulations cause a horizontal change. So that means we need to reflect over the y-axis. So let's see if we can capture those two. All right. I think this is it. Yeah. Okay, let me show you something real quick. If I click on this, I mean, this is fine. I think that's it. So I'm gonna hit save. All I did was I just adjusted the base. When I changed the base from base 10 to base 1 by 7, that caused it to be like a decreasing function. And then we took that decreasing log function and we flipped it over the y and it gave us this. Okay, we're gonna hit save and let's go ahead and see what happens. Okay. Let me check one other thing on Zoom. I think the chat was okay as well. We're gonna let that be. On to the next one. The domain, right? So looking at the graph, or normally the domain of a log goes from 0 to infinity, but because that base is between 0 and 1, now the domain is going to go from negative infinity to 0, but it's still going to be an open interval. So we're going to do double parentheses, negative infinity to 0. And again, if anything is not clear, feel free to unmute yourself and get my attention. If you're mute, then I can only assume one of two things. Either you get it or you don't, but I can't I can't go further or give an alternate view without interaction. Let me see the range of the function. So the range is just going to be the very bottom to the very top. So I know it looks like it flattens out on the bottom, but it actually doesn't. It steadily continues to go down as you go to the left, right? So the range here is going to be negative infinity to infinity, all rows. And that's not something I feel like if no one told you, or if you hadn't experienced that in advance, it's not obvious, right? The vertical asymptote, you can kind of that was a little bit more obvious, but if you were trying to do this with like no assistance, that range is not obvious. But a lot of this is just an experience, and then the more you expose yourself to these concepts, the more comfortable you'll get with them. If you don't expose yourself to them, if you don't try, you won't be comfortable. But the confidence comes through repetition, right? That's where it comes from. So we're just gonna let that be and keep it moving. Okay. The vertical asymptote is the y-axis. So that's x equals 0. Okay. We are moving and grooving. Okay. So another transformation, right? We just take the generic log. This is going to be a log base 4. We added 2 on the inside, so that 2 units. So we're just going to say 2 units to the left, right? To the left. Click to graph. So the log function is the upper right. We're going to click on log, and I'm just clicking on the graph. The base is 4, and we said a horizontal shift left by 2. Okay. I think our base got changed. I mean, something else got clicked. It keeps automatically clicking things. Come on. Trying to pull up my menu again. Okay, and then yeah, for some reason it keeps auto reflecting over the X. Okay, we're better now. That looks good. Let's hit save and check. What's the domain, right? So the very left to the very right normally is 0 to infinity, but we move left by 2, so now it's going to be -2 to infinity. The open interval, -2 to infinity. Okay. Vertical asymptote is x equals -2. Okay, on to the next one. We are like moving and grooving. Click to graph. Okay, we got 2 transformations. We got a -2 on the inside and a +2 on the outside. So let's go like this so we can see it somewhere. No? Okay, that's fine. We'll just work with it. We're doing a log and then click to plot. So we said the base is 3 is fine. We said we had a -2 on the inside. So that's going to cause a horizontal change. It's going to cause it to go to the right by 2. So 1, 2. And then +2 on the outside is going to cause it to go up by 2. Okay. So it should have gone right 2 and up 2. Did it go up 2? I don't think it went up 2. Let's check our thing again. Come on. So to bring the menu back up again, I just keep clicking on the curve. Vertical stretch. That was the wrong one. We want to do a vertical shift by 2. We want to go up by 2. Okay. Let's look at that one. So the reason I knew it didn't go up by 2, because the log function also passes through the point 1, 0, right? So we went right by 2, and if we go right 2 and up 2, if I follow that point, if we go 1, 0, now we go right by 2, now it should be what, 3, 0, and then up 2. So it should have passed through the point 3, 2. right? And it wasn't. It was passing through 3,0. So I was like, wait a minute, we didn't shift it up. So then that was a flag. So again, log function, one of the key points that log function passes through with no manipulation is 1, 0. So then a lot of times after you do your transformations, you can track that point 1, 0, and you'll get a sense of, you know, at least it was in the right position, if your graph is in the right position. And so when I saw that that key point wasn't there, that was a flag. And I was like, wait a minute, we clicked on something wrong. Okay, let's go with that. Okay. Let me check Zoom really quickly. See if we can stragglers. We do have a straggler. Okay, let me go ahead and capture him. Right there, hit save. Okay, let's keep going. So evaluate without a calculator. Let's take some notes here. All right, let's take some notes. So I usually like to get a copy of the header, so that way as we reference these in the future, we know where it's coming from if we wanted to use the text. Okay. Okay, cool. I think I can use insert last image. All right. Okay, evaluate without using a calculator. Okay, so I'm just gonna break these apart, right? I'm gonna do the inside part first, right? So if we focus on this log base 2 of 16, again, what I'm gonna do is set that equal to y, and then I'm gonna rewrite it as an exponential. So I'm gonna swing the base. The base of the log is now gonna become, wait a minute. I mean, I guess we could do this. I just thought of another way I could do it. But I feel like this still might be more simple than this alternative that I'm thinking. So when we rewrite this, we're going to get 16 equals 2 to the power of y. Now, if we wanted to solve for y, we need to get these to the same base. 16 is the same as what? 2 to the power of 4? 2 to the power of y, right? So then these two exponential expressions are equal if and only if their exponents are equal. So then that means y equals 4, right, for that first part. So then we can take that 4 and plug it back in. So now we're going to have log base 2 of 4. And again, I'm just going to set it equal to y this time again and swing the base. So then we get 4 equals 2 to the power of y. So then 2 squared equals 2 to the power of y. Y equals 2, right? So then that's doing it without a calculator, and it does not hurt to just see how it's with the calculator, right? So with the calculator, we can use the change of base formula, right? So we can do the following. Let me think about this. So we want to say log of, now the inside part, if we wanted to do change of base, we would say log of 16 divided by the log of 2, right? And then we need to capture that outside base. So I'll close off the outermost set of parentheses. Then I'm going to say divided by the log of 2 again. All right, that's the change of base formula. Because normally in the calculator, where it says log, that's base 10. So if we want to change the base from base 10 to a different base, we got to say divided by whatever base we want. That's the change of base formula, okay? So then if we did this correctly, we should get 2. Okay. Okay. All right, so we got 2. Okay. Next question. Evaluate or simplify the expression without a calculator. Okay. So essentially E and natural log are inverses of each other. So they just cancel. So that results just 140. I think I had a student that requested like for me to sit down with the homework, work on the homework with them. I was like, I don't really do that, but I mean, I'm doing it now. And I just know that like you all should have different numbers. You'll have the exact same questions with different numbers. I usually live stream these sessions, so you can always like, I really like that system because anybody that wants to pull a copy of it or go back, you can always pull it up and like go back and pause, rewind, slow down. You know, you can do what you need to do and do it's there. You have a copy of things that I already intend to say with these questions. And then whatever questions we don't do together, then you just bring it to my attention and we can talk about those. Begin by graphing this. Use transformations of this graph to graph the given function, blah, blah, blah. Okay. So let me hit click to enlarge the graph. We want the log tool, which is second row on the left. It says click to plot, so I'm just clicking on the graph. The base is E already. Now we added a +3 inside our base function, right? So the base is E, because natural log is just common log base E. So then when we add 3 on the inside, that causes a horizontal change, that causes it to move to the left by 3. So horizontal shift, we're gonna capture this by typing -3. Okay, I think that's the only manipulation. And it did not capture it. There it is. Okay. All right. I think that's it. Let's hit save. Let's check. Let me think. Did we click something else? Let's check it one more time. Base E, horizontal shift, stretching. Yeah, that should go left by 3. Let's begin by graphing this graph. Oh, okay, we're missing. They want that asymptote. Okay, that's fine. We're gonna close this out. We're gonna click on this to edit. It says graph the asymptote as a dashed line and then use a graphing tool, blah, 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 right? So let me close this out. Click to enlarge, there we go. So we want the vertical asymptote, this guy. How do we click here? Click a line or point to select it. Maybe like this and like that, and like here and here, right? I think that's good. So they wanted us to graph the vertical asymptote. That's what we were missing. And so to do that, what I did, I clicked in upper right, the line tool, and then the dash line tool because they wanted it to be graphed as a dash line. So not only did we have the log, but we also had the vertical asymptote. And then to graph the line, I just clicked 2 points on the line, the vertical line of x equals -3. Hit save, and let's check that one. That was interesting. I like that they added that extra part about the asymptote. Oh, I got a notification that Beautiful Mind is live streaming 26 minutes ago. Awesome sauce. Let me charge my phone because I usually like to go for walks after you walk. So at least my phone can have some kind of life on it and not be completely dead. I don't know if you guys like, I listen to a lot of like self-help stuff. There's a guy on YouTube I follow. His name is Infinite Waters Ralph Smart. His journey is very interesting. Like I've been following him for over a decade, and it's a clear distinction. You can see when he first started streaming, he was just doing it just because, and then he became popular. But he talked about all the stuff that I intend to talk about, and I just be making excuses to not do it. But he actually did it, but it took him like some time. But now it's like, I mean, you can see like the wealth. He has like 2 million followers. It's really interesting, his story, and it's inspirational. Okay, let me see the time. We got a solid little over 10 minutes. Let's keep going. What is the equation of the vertical asymptote? X equals -3. And like I never stream my game, and I be thinking about it. I just like, man, I don't know, -3. Let's keep it going. Okay. What's the domain? So normally the domain is 0 to infinity, but because we moved it left by 3, it's going to be negative, the open interval -3 to infinity. Okay. The range is the very bottom to the very top. So for logs, all rows. Nope. Negative infinity. Let's see the time. I might let you guys get out of here a little bit early today. It depends how long it takes us to finish these next couple of questions. Because it's pretty close. We got 3 more. So this one and 2 additional. Okay. For the following function, briefly describe how the graph can be obtained for the graph of the basic function, then graph. State the domain and the vertical asymptote. Okay. So we have 2 transformations, right? We take here, it says the graph of this is a transformation of the graph of natural log. So we multiply the outside by a negative. So when we're working multiple transformations in one go like that, the recommendation is to work your way from the inside of the function to the out, right? So there were no manipulations inside the basic function. So then the first manipulation is that times that -1 on the outside. So if we multiply a negative outside of our basic function, that causes a vertical change. Outside manipulations generally cause a vertical change, and it's going to cause it to flip vertically over the x-axis. So reflect across the x-axis, and then we added a positive 14 on the outside. So that's going to cause it to go up 14 units. And again, if anything is not clear, you have to unmute yourself and get my attention. Let me check. Let's go on to the next one. So then we're asked the graph, just clicking. The log tool is in the upper right. I'm just clicking anywhere. We got our base E. We multiply the outside by a negative, so we need to flip over the x-axis. And then move it up, vertical shift up 14 units. Oh. I'm trying my pen, maybe that'll work. Did we get to 14? Okay, that looks good. All right, let's go with that. Let's hit save. Let's see. Graph the equation. Graph the function and state the domain and the vertical asymptote. Okay, they didn't access the graph, the vertical asymptote this time. The domain. Domain is the very left to the very right. We did not move it left to right at all. So it's just going to be 0 to infinity. Oh, come on. 0 to infinity. Okay. Then the vertical asymptote is the y-axis, which is x equals 0. Okay, let me see the time. Is he live? The calm before the storm. Okay, yeah, she stayed live. How long does it take for a deposit of 13 to double at 5% compounded continuously? Okay, we'll just take some notes. Well, we have this like doubling formula. There's like a half-life / doubling formula. The simple way I remember is KT equals the natural log of 2, like for it to double, right? So if it says how long, that means we're trying to find the doubling time, because it says for it to double. We could use a continuous compound interest formula, but I'm just going to use the shortcut. KT equals the natural log of 2. So if we're solving for t, that means we're going to do the natural log of 2 divided by the rate. Think about it. Yeah. Natural log of 2. Okay. So let me see. I didn't even use the 1300. Let's see. Let's see if that works. If it doesn't, we'll go back and adjust. So natural log of 2 divided by, now 5% as a decimal, it's going to be 0.05. So this is years, right? So 13 years. So then we need to convert that 0.86 to months, right? So first, let me knock off the 13. So now we have that decimal. That's years. We need to convert years to months. So then basically you multiply by what? 12. Because 1 year is 12 months. So I'm just going to say that times 12. Oh, that's months. Wait a minute. Okay, let's go back. Let's go back. Let's say divided by 12. Okay. Sorry, they want days, right? So again, the units here are years, and it's 365 days in a year. So then we say this times 365. I don't know if they're using 365 or 365 and a quarter, but I'm just gonna go with this. So it's either 314 or 315 days. Let's put 315. Yeah, let's try 315. And then we'll try 314. Okay, that's fine. That was an adventure. Let me see the time. Oh, we are. I should not have been. Oh, did we finish? We did. Okay, we did get out a little bit early. I was going to be like, I shouldn't have got your hopes up about getting out early, but we did finish it a little bit early, so I'm okay with that. Let's hop back over here and let me go ahead and share a copy of these notes with you all. I'm going to share. I'm going to send it to Box. Not for calculus. We want to send this to the spring, College Algebra. Answered homework questions. So I'm putting it to the answered homework questions section. Let's see if I can think of no major announcements again. So we're gonna, I think exam 2, which is like a little over 2 weeks out, is gonna be basically over chapter 3, right? I can't think of anything else, gentlemen. Just kind of keep working and just, enjoy your weekend. So work hard and play hard. So get out, exercise, have some fun, enjoy your college life, do what enjoy yourself. But do your work. Make sure to get your stuff done. Okay, guys. All right, take care. Enjoy the rest of your weekend. And from one beautiful mind to another, take care. Peace.
All right, Professor, have a good one.
Yep, you as well. All right. Stop. Any other questions? Going once, going twice. Forever hold your peas and rice. All right.